What measurements can a multimeter take in electrical testing? Have you ever wondered what a multimeter can actually measure when it comes to electrical testing? This handy tool is a must-have for anyone working in electrical engineering, especially during prototyping and testing phases. Let's break down the key measurements a multimeter can take and how they fit into professional development and project management. First up is voltage, measured in volts. This tells you the electrical potential difference between 2 points. A multimeter can measure both direct current voltage and alternating current voltage. This is essential for verifying power supply levels and battery voltages. Next, we have current, measured in amperes. This measurement indicates the flow of electric charge through a circuit. Depending on the type of multimeter, it can measure both direct current and alternating current. Many multimeters have separate ports for high current and low current measurements, which is handy for checking circuit loads. Resistance is another important measurement, expressed in ohms. This tells you how much a component opposes the flow of current. It is used to test resistors and check the continuity of wiring. Continuity tests can quickly show if a circuit is complete, which is vital during the design phase. Then there's diode testing, which measures the forward voltage drop of diodes. This helps you check if diodes are functioning properly, an important aspect when working with semiconductor components. Some multimeters can also measure capacitance, which is expressed in farads. This is useful for testing the health and value of capacitors. Additionally, advanced multimeters can measure frequency, expressed in hertz. This is particularly useful in signal and power analysis. Temperature measurement is another feature found in certain multimeters, using thermocouple probes. This can be beneficial when you need to monitor heat levels in circuits. Lastly, continuity tests are a quick way to check if 2 points are electrically connected, often indicated by an audible beep. This simple function can save a lot of time when troubleshooting. In the context of project management and design, these measurements are vital. They allow engineers to verify circuit functionality and identify faults early in the development process. For instance, measuring voltage and current ensures that circuits operate within design parameters. Resistance and continuity tests confirm proper connections, while diode and capacitance tests verify the condition of components. When it comes to using a multimeter, it's important to connect to the correct ports. The common port is usually linked to the circuit ground or negative terminal, while other ports are designated for specific measurements. Using the right port and setting ensures both safety and accuracy. In summary, a multimeter is an essential tool in electrical testing, capable of measuring voltage, current, resistance, continuity, and more. These measurements support effective prototyping, testing, and troubleshooting of electrical circuits, making it a key instrument for anyone in the field of electrical engineering.